Alright, we're going to be working on this together. We'll be working along. So let's look at the example problem already given. A girl travels 20 miles on a bicycle. The trip takes 2 hours. Express her speed in miles per hour. The first step in doing these problems is to identify the variables in our problem. So we have 20 miles. That is your distance. 2 hours is going to be our time. We next identify the correct equation. So speed is equal to distance divided by time. And then we plug those values in. We then perform the calculation and we get the answer is 10 miles per hour. So looking at the next one, a car starts from a stoplight. They're at a stoplight. Your initial speed is 0. Traveling with a 10 and is traveling with a 10 meter per second. So that would be your final velocity in 20 seconds. Your time. So this would be final. This would be initial. That would be your time. So we identify our equation. Our equation is going to be final velocity minus initial velocity divided by t. Plug in our numbers and then perform the calculation and you'll get half a meter per second. So going over the terms, constant velocity or constant speed means that your speed does not change. Velocity includes a direction component even if we don't specify it. Frame of reference is the background used to judge motion. If it doesn't tell you, we'll assume it's just the Earth's surface. Instantaneous speed is the speed at a given moment in time, what you're currently traveling at, or what you traveled at the beginning or at the very end. Speed is the amount of distance traveled in a certain amount of time. Average speed is total distance divided by total time. We won't be going into time distance graph today, but it's a graph showing the speed of the object. Acceleration is the change in velocity over time. Motion is an object changing position or distance in time. And rate of change is the amount of time it takes to change position or motion. So let's do the first problem. So, what is the speed of a rocket that travels 9,000 meters in 12.12 seconds? So, first thing we're going to do is identify the variables. 9,000 meters, that's your distance. Your time. And we're looking for speed. So speed, and we usually use V for speed and velocity. So we're looking for that. So looking at our triangle, V is distance over T. If we're trying to find speed, we would use V equals distance divided by T. And plugging that in, that'd be 9,000 meters divided by 12.12 seconds. By the way, I haven't done this in a year, so I don't have any of these answers memorized. Make sure you include a unit.
So you don't round, you just do the last 2 digits?
I prefer at least 4 digits, 4 numbers, at least 4. I usually like 5. 5 is a good number. So 1, 2, 3, 4, 5, and a decimal point. Do not round, and if you because I have So every single time, so 1.9999. If I ask someone to round it to a single digit, they put 1. Isn't this really, really close to 2? My problem is most students do not know how to round. If this digit is 5 or greater, this one goes up to 2. My solution to this is make you like lots of digits. Because if this number had a 9 after it, this 7 should turn into an 8. But it didn't, it had a 4. So what is the speed of a jet plane that travels 528 meters in 4 seconds? So we have the distance d, our time, and we're looking for v. So again, it would just be d is equal to 528 meters. T is equal to 4 seconds. And your velocity is what you're looking for. So circle v. And that gives you d divided by t, which would be 528 meters divided by 4 seconds, which is 132 meters per second. So let's break up number 3. It says how long. How long is going to be your time? Will your trip take in hours? If you travel 350 kilometers, so that's your distance, with an average speed of 80 kilometers per hour. So we're looking for time. We're given a distance of 350 kilometers per hour. And our speed is 80 kilometers per hour. So solving for time, time is going to be equal to d divided by speed. Distance divided by speed. Plug our numbers in. 350 kilometers divided by 80 kilometers per hour. And that is 4.375. Units for time, as we used hours, or we'll have hours here. Easy enough, right? So how far in meters? That's going to be your distance, d, you're looking for. Will you travel in 3 meters? That's your time. 3 minutes. At a rate of 6 meters per second. That'd be your v. So we're looking for d. We're given a time of 3 minutes with a velocity of 6 meters per second. I'd like y'all to try doing that one on your own. Wait until everyone finishes. Just put your calculator and pen down whenever you finish so I can tell you're done. Everyone good? So what'd y'all get?
18.
Anyone get something besides 18?
Okay, 1,080.
1,080. Who got 1,080? That's the correct answer. So, this is in meters per second, or time is in minutes. We need to do some conversion. How many seconds are in 3 minutes? So how many seconds are in 3 minutes? So that's equal to 180 seconds. So we need to make sure our units match. So using our triangle, VDT, and we're solving for distance. So distance is equal to velocity times time. So our velocity was 6 meters per second. A time, we would use 180 seconds. We do this so that the seconds will cancel each other out. And then you get 1,080 meters. Meters is a unit of distance. So be careful when doing these problems. If it tells you minutes, you'll more than likely need to convert it into seconds if you use seconds here. On the previous problem, we didn't have to do that because, I should say. So in this problem, this was in seconds, so we could just use to get our answer in seconds. So let's do number 5. So a trip to Cape Canaveral takes 10 hours. That's time. The distance is 816 kilometers. And we need to calculate speed. So speed is simply distance divided by time. It's always good to write your given variables out. So plugging it in, 816 kilometers per 10 hours. That would be 81.6 kilometers per hour. How many seconds will it take for a satellite to travel 450 kilometers at a rate of 120 meters per second? So I'd like you all to try that one by yourself. Nicole, would you mind closing the door? I will say that this one has another conversion in it. This is in meters, and this is in kilometers. 450 kilometers, it's the same thing as 450,000 meters. Everyone finished? What'd y'all get? Did everyone get 3,750? Anyone get anything different? So our distance is 450 kilometers. However, we need to convert that into meters. This corresponds to our speed. So a speed of 120 meters per second. And we're looking for how many seconds. Seconds is our time. So we are looking for time. Time is equal to distance divided by our speed. So time is equal to distance divided by velocity or speed. Plug in our numbers. Our distance was 450,000 meters divided by 120 meters per second. That gives you an answer of 3,750 seconds. So work on the next problem. Again, check units. Do any conversions necessary. By the way, do y'all know how to who does not know how to convert minutes into seconds? Because I had people last year not know how to do that. They couldn't tell me how many seconds were in 2 minutes. Oh yeah. What really tripped people up was not knowing how many minutes were in 30 seconds. Their brain couldn't process the fact. 30 seconds is less than a minute. But can't you convert 30 seconds into minutes? Isn't 30 seconds a half a minute? So it's 0.5. So what'd y'all get?
1.2.
1.2?
For meters per second.
Did anyone get anything different?
I got 0.833.
So 1,000 meters is our distance, 20 minutes is our time, and we're looking for meters per second velocity. So we're looking for its speed His distance is 1,000 meters. Time is equal to 20 minutes, but we need it in meters per second. So we multiply this by 60. So 1,200 seconds. So velocity, distance, time. We are solving for velocity or speed. So V is equal to distance divided by time. That would be 1,000 meters divided by 1,200 seconds, which is 0.83 carried meters per second. All right, move on to the next problem. Actually, we'll work on problem 8 together. So this one is using acceleration. Acceleration is VF minus VI divided by T, or putting it in the triangle format, that's VF minus VI AT. So we identify the variables. 15 seconds is going to be a T. Initial velocity, so this will be our initial velocity, which is VI. Final velocity, and we're solving for acceleration. So our T is 15 seconds, or VI is 0.8 meters per second, and our VF is 7 meters per second, and we are looking for acceleration. So solving for A is equal to VF minus VI divided by T. So I would always put this in parentheses. That'd be 7 meters per second minus 0.8 meters per second divided by 15 seconds. And that gives you 0.413, and the 3 is carried. And our units would be in meters per second squared. I take 1 point off for every wrong or missing units. So make sure you always put the correct units. Acceleration is going to be a meter per second per second. So we have meters per second, or meters per second squared. Now try number 9 by yourself. Everyone get an answer? They're still working. So a meteoroid changed velocity or speed from 1 kilometer per second to 1.8 kilometer per second. So it changed the speed. Its initial speed or velocity was 1 kilometer per second to its final speed in a time of 0.03 seconds. So we have VI is equal to 1 kilometer per second. VF is going to be 1.8 kilometers per second. And our time is 0.03 seconds. And we are looking for its acceleration. So we're looking for acceleration. So acceleration is going to be VF minus VI divided by T. So plugging that in, that would be 1.8 minus 1 divided by 0.03. When putting in a calculator, I always put parentheses around these terms. You should get an answer of 26.6 carried. And our units for acceleration are going to be kilometers per second per second. So kilometers per second, or you could put equivalently 26.667 kilometers per second squared. I will accept units in either of these forms, but the second square is preferred. But you can just look at the velocity, it's kilometers per second, and then we do a per time unit. So it's kilometers per second to get the correct units. So try working on number 10. Anyone struggling to do this and need help? We do have Nicole, so don't be afraid to ask her to come help and explain. Everyone get an answer? What answer did y'all get? So a car is going 50 miles per hour, so that's its initial velocity. 5 seconds is going to be its time, and 80 miles per hour is going to be its final velocity. So we got VI is equal to 50 miles per hour. VF is equal to 80 miles per hour. Time is 5 seconds, and we're looking for acceleration. So acceleration is VF minus VI divided by T. So that would be 80 miles per hour minus 50 miles per hour divided by 5 seconds, which would be 30 miles per hour divided by 5 seconds, which is 6 miles per hour per second. Make sure your units is miles per hour per second. If you were to have said the answer was 6 miles per hour, you would get points taken off for not having the correct units. Miles per hour is a velocity or speed, not acceleration. Work on the next 3 problems. When you're done, I'll come check them. Oh, what's that card for? What's going on? Wait until we get the major profit rebuild a game. Where we want it to be. It's your game.
They have to do like a shortcut with new stuff. Like maybe repeat the same step.
That's what I was saying in class is, you can create a function to draw a square. And what you normally do is you create functions to achieve a certain task. So you have to go in and manually say, go to this corner and redo that. What you do instead is you say a square and use the bottom left corner as you go draw a square at this place. And it'll be have a height of this, or a rectangle, have a height of this and a length of that. Yes. Chris. No, you can keep it there. Do I vote? Oh, yeah. It won't say charge though. Do I get an answer? Line is missing unit. The number is right, but something else is wrong now. This one, units is wrong. So that's our velocity units, meters per second is velocity. Acceleration is meters per second squared. So you need to add a square to it. All the units are wrong. Meters per second is a speed. So you're looking for acceleration. So it's 50 seconds squared. That'd be 3 points off. 1 for every ball. Anyone else finish? Correct. Correct. No. Take it back. All your units are wrong. Yes, you don't put 2 seconds, so it'd be meters per second squared, or you can remove the square. Yeah. So either remove the square or. That's another thing. Yeah. Anyone else? You finished? Correct. There's something wrong with this. The number's right, the minutes right, but there's something wrong. That's right. Correct. The number's right, the units are right, the something else is wrong. Anyone else finished? The units is wrong, the units is wrong. All right. Let me go over one thing. So on this one, number 12, your initial velocity is 12 meters per second. Your final velocity is 0. So when you plug this in, A equals VF minus VI divided by T. You should get a negative answer. VF is 0. VI is 12. Our time is 36. So that gives you an answer of negative 0.3 carried. Another thing, whenever you're writing this, make sure the dot is bold and you include a 0. Put your calculator up.
Can you keep the paper or can we give it to you?
You keep it.